So now we are going to discuss about binomial random variable. So consider an experiment which consists of n Bernoulli trials. Now this experiment need to satisfy certain conditions, and here you see those conditions. So there need to be identical Bernoulli trials, and then two possible outcomes for each Bernoulli trials, and then Bernoulli trials are mutually independent, which is very important. And then the probability of success on each Bernoulli trial is identical. So when you go from one trial to another trial, the success probability should stay same. So once we define, if you have experiment like that, and the outcome, we can measure using this random variable, y, which is defined as number of success of these n trials. Then the distribution of that random variable is called as binomial probability distribution. The probability mass function is given in here. So basically, y is sum of n Bernoulli trials which satisfy these conditions. Okay, so each xi is Bernoulli with success probability p. So of course, since each Bernoulli trial can be either success or failure, y can take values between 0 to n. Okay, it can be 0 success, so all end up with failure, or every trial end up as success. So n trials end up as success. We would write this distribution as binomial with parameters. This is number of trials, and this is success probability, which is constant from one trial to another. So next, we would like to calculate mean and standard deviation of binomial random variable. One method you can use using that those conditions, mutually independent and identical Bernoulli trials. So I can write this as, and then the expected value is going to be, since they are independent and identical distributed, this is going to be n time one trial expected value, which is going to be p. Okay, we know from that Bernoulli trial discussion. And the same way variance, since they are mutually independent and identically distributed, I can just take this as n time variance of one trial, n time p time 1 minus p. Okay. So that's the mean and variance. Another method would be you take the moment generative function, which defined as expected value of e to the tx. Okay. So I can expand this. It's basically probability. Binomial random variable taking these values, time e to the t k. And the probability x equal k from here, it's given here. This is the probability mass function, so I can substitute that. So that's going to be nk pk 1 minus pn minus k e to the tk, and then I can make it a bit a nice rearrangement. And this is basically a binomial theorem. If you expand x plus y to the n, this looks like that. This is x, this is y, and this is binomial position. So, so this is going to be binomial expansion of 1 minus p plus. To get the first moment, you can differentiate this and say we're at 0. So it's going to be n time 1 minus p. And then at 0, that's going to be that's going to be np. Okay. So you can same way you can calculate the second moment. This is basically expected value. Okay. So you can take the second derivative, you will get 0. And then that would give you the second moment, and from there you can get the variance, which you can try yourself. So here you can see several questions asking you to calculate probabilities. So probability x equal 4. You can use given data. This is what? If you use the formula, this is 10. Choose 4. And then I have p 4, 1 minus p, 10 minus 4. So 10 factorial. P is 0.7 to 4. This is 0.3 to 6. Okay. Remember that we are still in discrete random variables. So if someone asks you to calculate probability 3 less than equal 3, random variable taking more than or equal 3, that is same as you are calculating a value from 3 all the way up to 10. Okay. It should be hard unless you use some calculators. Another way you use the complement, that's going to be 1 minus probability x less than 3. And then calculate this one. So x can take what? X can take only 0, 1, or 2. So you can expand that. It should be easy to calculate. So now you can individually calculate these terms and get the final answer. So here you can see another question asking x less than x value of x. So what's the ex? NP. In this case, n is 10, p is 0.7. So it's 7. So you are calculating really probably x less than 7. It is going to be, you can go the other way, 1 minus probably x more than or equal 7. Using complement rule. That's going to be probably x equals 7 all the way up to probably x equals 10. Okay. So you can do this kind of problems and practice your skill. So here another question. Suppose x is a binomial random variable with parameters n equal 4 and p equal 0.4. So n is 4 and success probability is 0.4. Mean is NP. Standard deviation, which is square root of variance, which is n time p time 1 minus p. So you can, and these two you can do. So use the formula. Okay, let's do 2 problems, maybe 1 problem, and then the rest I will leave. You can try, and if you don't know how to do, you can ask in the discussion board. So here you can see a study is being conducted in which the health of 2 independent groups of 10 policyholders is being monitored over 1 year period of time. Individual participant in the study group drop out before the end of the study with probability 0.2. Calculate the probability that at least 9 participants complete the study in one of 2 groups, but not in both groups. So if we take one group, we want at least 9 to complete. So X would be successfully completing. In the failure, so number of, this is number of policyholders successfully complete the study. Okay, so since we are using 10, so X can be 0 all the way up to 10. 0 mean everyone drop out, 10 mean everybody stay until the end of study. And we want to first know at least 9. So basically probability X more than or equal 9. Since it's binomial, this is basically probability X equal 9 plus probability X equal 10. I mean, it's discrete random variable, so you can have. So this would be 10 Choose 9, and the success probability is dropout probability 0.2. So success probability is 0.8. So N is 10 and P is 0.8. And then everybody successfully complete this. This is 0.8 to 10 time 0.2 to 0. Okay. So that would give you per group, for one given group, the probability of at least 9 completing the study. So now we have 2 groups. So I can say group 1, at least 9. Less than 9. In the group 2, at least 9, less than 9, at least 9, and less than 9. So we are looking for, since it says at least 9 parts complete the study in one of 2 groups, but not both. So we are looking this possibility. So you have to find the probability and then modify those 2 and get the answer. The other 2 problems I will leave. If you don't know how to do it, or you need help, please post in the discussion board.